Welcome to the second video in the similarity unit, proportions in triangles and parallel lines. The first thing we want to do is make sure we understand the difference between congruent and similar. For two triangles to be congruent to one another, all angles of one triangle must have the same measures as the corresponding angles of the other triangle, and all sides of one must have the same lengths as the corresponding sides of the other. That's just a long way of saying they must look like copies of each other, though you can place them in different positions. For two triangles to be similar, all angles of one triangle must have the same measures as the corresponding angles on the other, but the sides must share a constant proportion. Notice in our example that the length of the sides of the first triangle are twice the lengths of the corresponding sides of the second triangle. The easiest way of thinking of this is that their shapes must remain the same, but their sizes can be different. Much like taking this image of Han Solo from Star Wars and enlarging it, the image is the same, just a different size. Another thing we need to know is that if we bisect or cut in half any angle of a triangle, then we divide the opposite side into segments that are proportional to the other two sides. To see what this looks like, we will bisect an angle of a triangle. We have a little freedom as to how we set up our proportions. We can say the proportion of the long side over the short side of one triangle is equal to long side over short side of the other triangle, or vice versa. We could also say adjacent over short of one to adjacent over short of the other, and vice versa, or just writing the letters would be much easier. Now that we know the difference between congruent and similar figures and the angle bisector theorem, we can look at how to apply that knowledge. Here we have a couple of triangles and some measurements given to us. We want to find the value of x. Note that x is actually the entire length of a side of the whole triangle. So to find it, we will need to first find the measure of the shorter part of that side. We can set this up according to the angle bisector theorem and have the adjacent over opposite of one to adjacent over opposite of the other. Note the adjacent over opposite before my proportions. This doesn't affect the math, but it's just a way of ensuring that I keep my proportions all the same. Before we go any further, I want to reduce any fraction that I can to make the math easier. From here, we want to cross multiply. Because I'm multiplying the unknown by 2, and I want the unknown by itself, I will do the opposite and divide both sides by 2. My unknown side then is 15. I can now add the 15 and 24 to get the value of x. Let's look at another example. Here we have two triangles. Both triangles share a common angle, and two sides with the third side of each triangle being parallel to one another. If we review what we learned in our first video of this unit, we will find that all the angles are indeed congruent. To make this easier to see, let's separate the two triangles and label the sides appropriately. Now we're ready to set up a proportion. Just because I like my fractions with the smaller number on top, I am going to set this up as short over long. Filling in our values, we have 20 over the unknown is equal to 28 over 18 plus the unknown. Cross multiply to get 28 times the unknown equal to 20 times the quantity 18 plus the unknown. And using the distributive property, we get 360 plus 20 times the unknown on the right. We are going to subtract 20 times the unknown from both sides to get 8 times the unknown equal to 360. Divide both sides by 8, and we get the unknown side is 45. Let's look at one last example. I want to set this up as short over total side length. When filling my values, I need to remember to add the 2x minus 10 and the 9 to get the total side length. I want to reduce my fraction on the left, since 2 goes into both the top and the bottom evenly, and on the right I will simplify the denominator. Now I can cross multiply. I subtract 4 from both sides and add 50 to both sides, and I'm left with 6x equals 48. Divide both sides by 6 and x is equal to 8. That concludes our second video in the similarity unit.